Okay, so I will try to explain how to solve doubly reinforced sections. As per your syllabus, doubly reinforced beams are analyzed and it is designed. So we'll see how to solve doubly reinforced beams. So we'll read out the problem. A doubly reinforced beam of size 250 into 500 mm overall has to carry a maximum bending moment of 175 kN meter under working condition. Find the area of tension and compression reinforcement. Use M20 and Fe500 steel. Take an effective cover of 40 mm on both the sides. So by reading this, I can say this is a doubly reinforced beam. So we'll try to write a sketch here. So this is a doubly reinforced beam. It is given there. So the section is 250 mm. Breadth of the section is 250 and depth of the section as 500 mm. So it is given overall means we have to consider this value as capital D. So we will write here itself capital D is equal to and small b is equal to 250. And they are asking to calculate the tension and compression reinforcement. So if it is simply supported beam, the compression phase is at the top. So therefore these reinforcements are compression reinforcement. If you provide reinforcement at the bottom, then those reinforcement are defined as tensile reinforcement. These are tensile and these are compressive reinforcement. The area of reinforcement is unknown, so here the main aim is to calculate these reinforcement by using other given data. And they have mentioned about grade of concrete as M20 and grade of steel as 500. So I will try to mark these important given data. Bending moment, maximum bending moments at working condition means this is a moment, bending moment given. We have to calculate tension and compression reinforcement. The grade of concrete and grade of steel is given and effective cover is given. So I will list out here. B into capital D is equal to 250 into 500 mm. So effective cover is given. I will write here itself D dash is equal to 40 mm. So therefore I will calculate small d, capital D minus D dash. So I will explain here itself. So if somebody don't know about these parameters, please observe this explanation. So if this is a beam, if this is a reinforcement provided at the bottom, so there is a center line for this reinforcement, and always capital D is measured from the top compression phase. If we treat this as a compression phase, I am explaining at the bottom, therefore I am neglecting the top part. So this total depth will be capital D. If we calculate from compression phase to center of reinforcement is defined as small d, and center of the reinforcement to the bottom or any part, the side, it may be here or it may be here, it may be the top, anywhere. If you calculate that length, we will call it as d dash. So then the relationship between d, capital D, small d and d dash, capital D is equal to d plus d dash. So if you want to calculate small d, then it will be capital D minus d dash. So this is the formula we will want to use. So here we have written directly. So 500 minus 40, nothing but 460 mm. So otherwise you use the calculator and calculate it. 500 minus 40, it comes around 460 right here. So this is the required value. I will write the unit and I will mark this. And then the given value, which is the given value, mu is given. So 175 kilonewton meter, and then FCK is given. FCK is equal to 20 Newton per mm square. Fy is 500 Newton per mm square. So these are the given data. Okay, fine. So now we have listed the given data. I will mark a line for reference. So this is the line I'm drawing. So now we have to calculate mu limit. If you want to calculate mu, before that I will take this mu that is given 175 kilonewton meter in working condition means. So in limit state method, so we'll multiply this value, the given value, by 1.5, that is factor of safety, gamma f. 175 into 1.5, so you calculate this value, it comes around 175 into 1.5, so this will be 262.5 kilonewton meter. Okay, so I will write once again to mark this kilonewton meter, round off this value, this is important. And then if you want to calculate mu limit, I have formula that is known, so I will list out once again mu limit, and for different grades of steel I will list like this: 250, 415 and 500. So here this is known 0.138 FCKB into d square. As the grade of steel increases, this value decreases. So therefore this will be 0.133 FCKB into d square, and this value, if I am not wrong, 138, it has to be more than this. So this will be 148. I will check once. Okay, this will be 0.148 FCK B into d square. Based on this, I will select the formula. So this is the formula I am going to use now. So for this grade, this is the formula: 0.133 FCK B into d square. Substitute the value 0.133 into 20 into B is known 250 into small d is known, that is 460 square. Don't miss any powers or units values. 0.133 into 20 into 250 into 460 square. So it comes around 140714000. So what I have told you in the previous session, that you have to press this engineering keyword. So it converts as 140.71 10 into 10 power 6. Write this value as it is, 10 power 6. So unit will be Newton millimeter, or it can be written like this. So mu limit is equal to 140.71 into nothing but kilonewton meter. You can write directly this value like this. So this is also important. So next, again this problem is continued in the next page. So this is the continuation. So after calculating mu and mu limit, so in doubly reinforced beam we have a formula. So I know that formula, but for your reference I am referring from IS 456-2000. I hope on this stage you know that formula. So this formula is given in page number 96, annex number G. G 1.2, section with compression reinforcement, nothing but doubly reinforced beam. This formula is given: mu minus mu limit is equal to FSC AC d minus d dash. So I will use this formula to calculate that. So we have mu minus mu limit is equal to FSC into AC into d minus d dash. So I have written as it is: mu minus mu limit is equal to FSC AC d minus d dash. So write the formula and substitute the values. So here I will refer this page. So mu is now 262.5 and mu limit is now 140.71. So I will write here 262.5 minus 140.71. So without means you have to add 10 power 6. Why? Because we will write the area of steel in mm square and d will be in mm, d dash will be in mm and FSC also in mm. So FSC is not known, right, as it is. ASC is not known, we have to calculate. D is known, that is 5, how much it is? 460, small d is 460. 60 minus 40 mm effective cover. So here two unknowns are there, therefore we can't calculate ASC. To calculate ASC you have to calculate FSC. So therefore I will calculate, so I will call this as equation number 1 and I will calculate FSC. FSC can be calculated by using this formula. So FSC can be calculated by using this formula, 0.0035 XU maximum minus D dash divided by XU maximum. So what I will do is, I will just write the formula as it is, 0.0035 in the bracket XU maximum minus D dash divided by XU maximum, close the bracket, into Young's modulus ES. In the code book it is not mentioned, it is a typing mistake. ES is not mentioned, so you have to write ES in the page, in this page, don't write in the code book. So ES, that means stress is equal to this will be strain into Young's modulus. Stress by strain is equal to Young's modulus. If you multiply strain with Young's modulus, then it will be stress in steel. So substitute the values, 0.0035 within the bracket. XU maximum is not known, you have to calculate. XU maximum by D for FI 500, so is known. What is the value for 500.46? So you have to memorize. So in the previous class also I have explained about XU maximum by D. For if the grade of steel is 250, then it will be 0.53. If the grade of steel is 415, then it will be 0.48. If grade of steel is 500, then it will be 0.46. In this problem, XU maximum by D is 0.46. Why? Because grade of steel is 500. Okay, I have to memorize the three values for different grades of steel. So we have to calculate XU maximum. So therefore XU maximum is equal to 0.46 into D is known, that is 460. So you calculate this value, you will get 0.46 into 460 is equal to 211.6 mm. Write the unit. So this will be 211.6 minus 40. D dash is known, 40 divided by 211.6. Close the bracket. ES is known. Always ES is 2 into 10 power 5 Newton per mm square. So this is Young's modulus for steel, is always constant. So adopt the value as 2 into 10 power 5. Then calculate whole value 35 into use this option, 211.6 minus 40. Here you have to write 211.6. So again multiply by 2 into 10 power 5 is equal to, you will get 567.67 Newton per mm square. So this is stress, the unit is in Newton per mm square. So here we have a condition, it should not be greater than 0.87 into Fy, nothing but 0.87 into 500. So you will get a value 0.87 into 500. So 435 Newton per mm square. So therefore I will take this value as, why? Because this value is exceeding this value. In IS code book it has been referred that it should not be greater than 0.87 Fy. So this 0.87 is 1 divided by 1.15. This is a factor of safety. If if you calculate this 1.15, you will get a value 0.869. So these rounded up to point as 0.87. 69 is referred as 0.87. So this value, so this factor of safety is been introduced in steel. In the class also, while teaching the theory, I have explained you people that for concrete we have adopted a value 1.5 as a factor of safety. For steel it has been adopted as 1.15. So this is the explanation of this value. It should not be greater than this. So therefore it has been limited up to 435 Newton per mm square. So round off this value is also important now. So by knowing these, you can calculate ASC. Substitute here. So I will substitute in equation 1. I will write here. Use FSC is equal to 435 Newton per mm square in equation 1. So substitute here. So I will write once again 162.5 minus 140.71 into 10 power 6. So whole bracket ಹಾಕಿ 10 power 6 ಹಾಕಿದ್ದೀನಿ. FSC is 435 into ASC into 460 minus 40. Then you calculate ASC. So ASC ಇಲ್ಲಿ ಇಟ್ಕೊಂಡು ಇದನ್ನು ಈ ವ್ಯಾಲ್ಯೂ ನ್ಯೂಮರೇಟರ್ ಅಂತ ಇಟ್ಟು ಇವೆರಡನ್ನೇ ಡಿನಾಮಿನೇಟರ್ ಕಳಿಸ್ಬೇಕು. ಸೊ ನಾನೇನು ಮಾಡ್ತೀನಿ, ಇದನ್ನು ಸೆಲೆಕ್ಟ್ ಮಾಡ್ತೀನಿ. ಸೊ ಬ್ರ್ಯಾಕೆಟಲ್ಲಿ 262.5 ಇಂಟು ಮೈನಸ್ 140.71 within the bracket into 10 power 6. ನೆಕ್ಸ್ಟ್ ಬ್ರ್ಯಾಕೆಟಲ್ಲಿ ಇಲ್ಲ ಹಂಗೆ ಹಾಕೋದು 435 ಇಂಟು 460 ಮೈನಸ್ 40. ಇಷ್ಟನ್ನು ಟೈಪ್ ಮಾಡಿದ್ರೆ ಯು ವಿಲ್ ಗೆಟ್ 666.61 mm square. So this is compression reinforcement. Next we have to calculate tensile reinforcement and as well as total reinforcement. So to calculate that, again refer code book page number 96. We have formula to calculate AST2. We have ASC, FSC and FY. By knowing this we can calculate ASC.